Good morning student. Today we are going to perform experiment number 4. Our objective is to study the performance of ice plant and determine the unit capacity of ice plant. In this experiment we required a apparatus is ice plant tutor. The schematic of ice plant tutor is we have already studied the various component of vapor compression refrigeration system. So these are the main component, and this evaporator are immersed into this insulated tank which absorb the heat from the brine, and this brine is called ethylene glycol, and this glycol absorb the heat from the water and converted into ice. Now move to the formula which we have used in this experiment, that is first is coefficient performance of the system, that refrigeration effect upon work input, which have already derived in the classroom. This is the actual COP of the system, mass into specific heat into temperature difference upon 3592 into energy consumption by the compressor in kilowatt hour. Number 3, the heat required for a unit capacity is equal to mCp delta T. This Cp is water, and this temperature difference, the water initial temperature minus final temperature, plus m into latent heat of ice plus Cp of ice, specific heat of ice. These are the formula which we have used in this experiment. This is the experimental setup of ice plant. It has a main 4 component. The first is compressor, condenser. This is the rotameter to measure the flow rate of refrigerant. This is the capillary tube as an expansion device, and this is the evaporator. These are the main control panel of the system. The first is main switch for the power supply, voltmeter, ampere meter for compressor. This is the temperature indicator to measure the various temperature of the system. The T1 is suction temperature, T2 discharge temperature of the compressor, T3 discharge temperature of condenser, T4 evaporator or brine temperature, and T5 is ice can temperature. This is the energy meter, is used to measure the consumption rate of compressor. This is the various switch. The first is the fan switch, the condenser fan switch, compressor switch, and this is the switch for agitator. These are the gauge which we have used for suction pressure of the compressor, discharge pressure of the compressor. This is the system which practically used in the ice plant. So this is the evaporator. It contains a ethylene glycol. The first evaporator observes the heat from the glycol, then glycol observes the heat from the ice can to freeze the ice inside the system. These are the components which we have discussed. Now we note down the temperature from the system T1, T2, T3, T4, T5 and calculate the COP and actual COP of the system. Come to the observation and calculation part of this experiment. In this experiment we have noted down the various value from the experimental setup, that is pressure P1 in pound square per inch, P2, T1, T2, T3, T4, and these are the temperature as is equal to this. And after that open 134A pH chart of the refrigerant and mark P1 and P2 and located T1, T2, T3, T4 temperature, and corresponding these temperature find out H1, H2 and H3. These value are putting into first equation and calculate coefficient of performance, that is equal to 4.68. Second part is actual COP, that is equal to mcp delta T upon this value into energy consumed by compressor in kilowatt per hour, that is equal to 90 into 3.2 into temperature difference upon this is equal to 1.18. This is the actual COP of the system. And third part is heat required for unit capacity is equal to mcp delta T plus mhfg plus cp of ice. That putting all value into this equation, the mass of the water which we converted into ice, that is 7.5 into 4.2, that is the specific heat of water, into temperature difference plus mass which we have converted into ice, that m, that is 7.5 into latent heat of ice plus specific heat of ice, that is equal to 8.64 kilogram per hour, and now it's converted into 207.37 kilogram per day. These are the result in which we have required. Thank you.